Welcome to 4-4A. Today we're going to teach the concept of basically creating an equation. All right, I'm going to talk about basically a four-step process. Number one is drawing a picture. Number two is creating an equation. Number three is creating a second equation. And then number four is plugging one of the equations into the other to create a quadratic. All right, so four-step process. You're going to see it in the chart on the next page. All right, in order to do some of our equations, we need to just have some background information. All right, so I'm going to just start here with a 45, 45, 90. The reason I am giving you this is I want you to think about a square. So think about in terms of a square, all the sides are equal. So this is where potentially this can come up if they talk about, like, say, the diagonal of a square. The 30, 60, 90, what you need to know is that this comes from the idea of an equilateral triangle, okay, where all the sides are equal. This would end up being the height of the triangle. So if you think about an equilateral triangle, this would be 60 degrees. Up here, this would be 30 degrees, and together these would create 60. So now we have a 60, 60, 60 triangle. All right, so just understand the relationship between these, okay? So for your 45, 45, 90, it is x root 2. What that means is if this is a 4, this is a 4, and then this is a 4 root 2, okay? And over here, when it says x, 2x, and x root 3, if x was equal to, say, 4, 2x would be an 8, and then this would be a 4 root 3. This all should be reviewed. You should have covered a little bit of this in geometry. All right, I'm going to skip down to this idea here. If you want to, you can pause the video and try and do these examples on your own first, okay? And then I will go through them. All right, if you had a chance to try them on your own, hopefully you came up with 3 and then 3 root 2. Over here, you're working backwards, okay? 10 is equal to x root 2, so to solve for x, I got to divide by a root 2, okay? That's one way to do it, and then you get 10 divided by a root 2. If you rationalize that by multiplying top and bottom by root 2, you're eventually going to get a 5 root 2. The other way to do this one is use the Pythagorean theorem, okay? You got x squared plus x squared is equal to 10 squared. You got 2x squared is equal to 100. Solve for x. You should eventually get 5 root 2. All right, down here with our 30, 60, 90, you need to understand that this is double the x value, so therefore x is equal to 6, and then this is 6 root 3. All right, this last example is similar to the second one. You have to set this equal to x root 3, which means I'm now going to divide by a root 3 in order to get my a value. Okay, so my a value, which is our x, is going to end up equaling an 8 over root 3, or when you rationalize it, you end up with 8/3 root 3. And when I double it, all I get is a 16 root 3 over 3, because I'm going to just multiply the 8 by 2. All right, we'll talk a little bit more about these when they come up. All right, things that you need to know over here. Your area formula for a rectangle. Some of you might use length times width. Some of you might use base times height. Doesn't matter. Triangle, you got your 1/2 base times height. Some of you say base times height divided by 2. Same thing. Trapezoid, base 1 plus base 2 times h divided by 2. This is my base 1. This is my base 2. And then my height, remember, has to be perpendicular. Okay? So there's my height. You've got your area formula for a circle versus circumference. Make sure that you are aware of that. When we have more complicated formulas like volumes and things like that, a lot of times I will give them to you, okay? Things that you should know All right, for example, surface area for a cylinder means that you have two circles. Well, the area formula for a circle is pi r squared, so you have 2 pi r squareds, two circles, plus your circumference times your height, so 2 pi r h. Down here, you got your formulas for sphere and hemisphere. The big thing that I need you to be aware of is your symbol here is an L. This stands for what we call slant height. That should be a reminder for you. Okay, and reminder that this is a right triangle. So the other thing to just be aware of is that r squared plus h squared equals L squared. Okay, otherwise it's asking for volume, but volume you have right over here. Okay, all right, so this is just background information. You need to know your area formulas, perimeter formulas, so on and so forth. Sometimes they'll give you that phrase, and you just need to be able to come up with the equation on your own. All right, let's take a look at an example. All right, so there's a 4-step process to this that I mentioned. All right, number 1, we're going to start by drawing a picture. Number 2, we're going to come up with an equation, and we're going to solve for one of the letters. Then we got to come up with a second equation, and then what we have to do is plug one of the equations in for the other. And our goal is when we get down here, we should have a quadratic or a quadratic-like. That means that we could have an x cubed or an x to the 4th, but we need to have at least x squared. All right, the first one. I want you to see if you can draw this on your own. So pause the video, see if you can draw it. And the reason is most of you are going to make a mistake on this, and I need you to learn from your mistake. Okay, so it says a rectangle is inscribed. You need to know what this word inscribed means. That basically means that the rectangle is inside of the circle. It has a diameter of 8. Express the perimeter of the rectangle as a function of its width, x. So we're going to have to explain what this means at some point. Okay? All right. See if you can draw the picture of a rectangle inscribed in a circle with a diameter of 8. All right, I'm going to actually start with things that people did wrong, okay, just so you guys understand, all right? So, for example, some of you may just do this. Sorry. Oops. Some of you may just put a rectangle inside. That's wrong. Inscribed means that the corners have to be on the circle, okay? So we can't have that. All right, so some of you may do this, which is fine, okay? But then when you go to do the diameter is 8, you're going to do this, okay? Or you're going to put the 8 up here. Now, what's wrong with this is the fact that the diameter that you're drawing has nothing to do with the rectangle. So our goal is to create it so that we make a connection between the rectangle and the circle. So what you're going to do is you're going to draw your diameter this way. This will pass through the center of the circle. This gives you a diameter of 8. And now that line also becomes the diagonal of the rectangle, which is what we want. All right, you should always label. So I'm going to add in our labels here. We've got length and width. Notice it says the width is x, so I'm going to change the width to an x. Okay, so I'm going to use that when I write my equations. Okay? All right. Starting out with a hard one, and the reason is one of our equations is not known. All right, so it says, what is a basic formula created by the question of the problem? Well, the one that most of you probably won't come up with is this. We have the Pythagorean theorem. So I've got an x squared plus L squared is equal to 8 squared. Okay? All Our goal is to rewrite the formula as a function. So since it says we want our final to be a function of the width of x, what that means is we need to have everything written as x's in our final equation. So that means I need to solve for L, get L by itself, so that I have it in terms of x. So I've got L squared equal to 64 minus x squared. And then when I take the square root, I get L is equal to the square root of 64 minus x squared. It is not equal to 8 minus x. Do not make that mistake, okay? Simple reason, order of operations, say you have to subtract before you take the square root, okay? All right, so do not make the mistake of simplifying this, all right? If you're also wondering why I didn't put plus or minus, reminder that it's a length and length can't be negative. All right, your auxiliary equation is based upon what it is asking. Well, it is asking for the perimeter. So my second equation is going to be perimeter is equal to 2 L's plus 2 X's, okay? You could start it as 2W if you want, but at some point we got to do X's. All right, our goal is to take one of our equations and plug it into the other equation. So when we're done, we should have P is equal to 2 times the square root of 64 minus x squared plus 2x. And it is a quadratic because of this x squared that we have here. Okay? All right. Reasonable domain. Think about this. X has to be greater than 0. And the reason it has to be greater than 0 is because you can't have a negative length. Number 2 is it has to be less than 8. And the reason is the hypotenuse is 8, so it has to be shorter than the longest side of the triangle. All right, let's try a second one. This one's going to be a little bit easier because it's going to explain a little bit more in terms of the two equations you have to come up with. All right, so you have a rectangle, okay? And it says it has a perimeter of 100, so I'm going to start by drawing a rectangle. Again, it wants its width to be x, so here's my length, okay? And I know that P is equal to 100. Okay, so my original equation is going to be 100 is equal to 2x's plus 2l's. I'm going to solve for L because I want to get it in terms of x. So L is going to equal a 50 minus x. Okay, my second equation, it says express the area in terms of x. So now I've got area is equal to L times x. Well, when I plug my value for L in, I am eventually going to get an A equal to 50 minus x times x, or A is equal to 50x minus x squared. Okay. All right, so notice I have a quadratic. That's the goal. Okay, so this is a very streamlined one. All right, your goal is to write two equations, solve for one of them for a letter, and then plug it into the second one to create a quadratic, okay? Our domain here, we should have x again has to be greater than 0 because you can't have a negative length. And then for this one, it has to be less than 50. Okay, and the reason is because with your perimeter equaling 100, two of the side lengths have to be less than 50. All right, third example here to work through. All right, I'm going to go a step at a time. Number 1, it talks about a point lies in the first quadrant. All right, let's draw the first quadrant. All right, next it says you have a parabola occurring at y equal to 16 minus x squared. Well, you should recognize that it's an upside down parabola because of the negative x squared, and that you have a y-intercept at 16. So I'm up here at 16. I have a parabola. So I'm going to draw my parabola in the first quadrant. I'm not worried about the second quadrant. Okay? All right, next, going back. It says that I have a point xy that lies in the first quadrant on the parabola. All right, drawing it anywhere. There is a point on the parabola in the first quadrant. Now the next part is a little tricky. Express the area in terms of a right triangular region as a function of x. All right, so I have to make a right triangle. I'm going to do that by drawing straight down to form a right angle. And then I'm going to draw the hypotenuse from the origin. All right. We have to label our triangle. Well, if you think about the idea that you have to go across x and up y to get to xy, this is x and this is y. All right. All right. We've got two equations. The first one, they gave it to you. So we've got a y equal to 16 minus x squared. Okay? And since it's already solved for in terms of y, you've got y equal to 16 minus x squared. Nothing happens when we have to go and get it. And again, remember, our ultimate goal is to always have x's at the end. So that's why we needed the y by itself. All right, the second equation is going to be express the area of the right triangle. Okay, well, area is equal to 1/2 base times height. So in our case, area is equal to 1/2 x times y. Since we know what y is equal to, we're going to plug it in down here. And eventually, our equation becomes area is equal to 1/2 x times 16 minus x squared. You can distribute if you want, but you do not need to. Notice again, we have at least a quadratic. If we distribute the x, we're actually going to have an x cubed here. All right, and then in terms of your domain, again, x has to be greater than 0 because you can't have a negative side length. Okay, and then from here, we would say that it has to be less than 4. Okay, just think about it in terms of like your x-intercepts. Okay, your x-intercepts, when you go to graph this, they're going to go to 4, 0, and they're going to go to negative 4, 0. So x has to be between 0 and 4. Okay, so keep that in mind. All right, so just going through. Number 1, draw a picture. Number 2, you got to come up with 2 equations. One of the equations you have to solve for a letter and then plug it in order to come up with a quadratic. All right, so just that's the goal. All right, we're going to practice this 2 more times. Okay, all we're doing on today's is we're just working on the setup. We'll eventually work on the solving in 4.5. All right, it says the volume of a right circular cylinder is 36 pi centimeters cubed. Express the total surface area as a function of the radius r. All right, so what that means is your final equation is only going to have r's. Now remember, pi is a number, it's not a variable. So no h's, no l's, no a's, or anything like, you can have a for surface area, so on and so forth, okay? But you can't have anything else, all right? So I'm going to start by drawing a right circular cylinder. Circle, circle, whoosh, whoosh. All right. Things that you need to label in this picture. Here's your R and here's your H. Okay? All right, volume. Okay, I'm just going to scroll back up here just so remind you I did give this to you. Okay, your volume for a cylinder is going to be pi r squared h. Okay, so since number 1 equation, volume equals pi r squared h, or 36 pi equals pi r squared h. All right, what we want to do is we want to get the h by itself so that we have h in terms of r. Okay, so keep that in mind because that way we can then plug it in. All right, so I'm going to start by dividing by pi. those are going to cancel out. I've got a 36 equal to r squared h. I'm going to divide by r squared, and I got h is equal to 36 over r squared. All right, I'm going to save this for later. All right, the second equation that I need has to do with surface area. Okay, surface area, I gave this one to you, is 2 circles, so 2 pi r squared, plus the circumference, 2 pi r h. Okay, now that I have this, I am going to take my h value that I solved for over here, and I'm going to plug it in. So surface area is equal to 2 pi r squared plus 2 pi r times 36 over r squared. Hopefully you recognize that this can cancel with one of these r's there, and then I can multiply the 36 times the 2, and surface area is equal to 2 pi r squared plus 72 pi over r. Notice that everything is in terms of r, okay? Remember, pi is not a variable, it's a number, okay? And it's a quadratic, so we did it correctly, okay? So again, picture, write 2 equations, solve for one of the 2 equations, plug it in, create a quadratic, okay? All right, last one. All right, a piece of wire, x inches long, is bent into the shape of a circle. All right, what you need to understand this is that here's your wire. It is x inches long. When I bend it into the circle, that x now represents the circumference. So it's equal to the circumference. Keep that in mind, okay? All right, it says express the area of the circle in terms of x. All right, other things that would be useful to know. How about all circles have a radius or a diameter? All right, we've got a couple of things that we need to have, okay? So to start, our first equation, let's start with circumference. Circumference equals 2 pi r, so x equals 2 pi r. I want to solve for r so that I have it in terms of x, which means I'm going to divide by 2 pi. So r equals x over 2 pi. My second equation is going to come from the fact that it says express the area of the circle in terms of x. Well, I need to know the area is equal to pi r squared. And since I now have r as x over 2 pi, I've got pi times x over 2 pi quantity squared. All right, reminder that when I go to square this, I got to square everything. So I've got pi times x squared over 4 pi squared. I can cancel this pi and one of these pi's. And so now I've got area equal to x squared over 4 pi. All right, notice when we are done, it is in terms of x. Our goal is, unless it says, like on the previous example, to have it in terms of r, your final equation should always be in the form of x. And then just so you understand why that is, in 4-5, we are now going to find the vertex so that we can figure out the max or the min. All right, you got 4.4a to do for homework.